mom's at lunch.
All right, number one. Again, if you get all the ideas down, guys, we're rolling out. If we get all the ideas down from these 6 problems, you are in, I'm not going to say it's perfect, but you're in much better shape than if you don't. If you don't, you're doomed. All right, number 1, it's conceptual. An object of mass m is initially at rest. After a force of magnitude F acts on it for a time, the object has a speed v. Here's where it's already confusing, because it's bringing in v and t. And the only thing I've told you lately is force equals mass times acceleration. And this is all one-dimensional, so we don't have to worry about the vectors today. We can treat it as a fairly simple algebra problem for today. Next week, vectors. But I did tell you a lot last semester that force equals mass. I didn't say force equals mass. That acceleration is the same thing as velocity over time. No, nothing squared.
Velocity.
It's distance over t squared. Good memory. Distance over t squared, velocity just over t. Because velocity, remember, is already d over t. So now we have an equation that talks about the velocity in time, which is what the problem asks for. It asks about changes in time, so I'm going to solve this for time. First, I'm going to divide both sides by mass. Then I'm going to cross multiply, which gets me that mass times velocity is the same thing as force times time, which can be a fun thing to think about if you want to give yourself a headache one afternoon. How is mass times velocity the same thing as force over time? We may actually come back to that a little bit. And now I'm going to divide both sides by force, and that's going to give me the expression that time equals mass times velocity over force. You can solve this for time and say that time is mass times velocity over force.
Why can't you just give us that yesterday?
I wanted to see who remembered this.
And did anyone?
No one did.
We remember it, but we're not going to know how to, like, wow. Maybe.
It doesn't mean you're going to implement it.
I know. I actually kind of planned for this. That's why I allowed today just to go over these problems. Okay?
Oh, it's such a slow day.
So now it's going to be. All right,
now
so.
you plug in, like, the mass is 2 times, and the F
Good.
is quadrupled.
Yep, the next part says what happens to time if you double the mass and quadruple the force. So now I write it as time equals 2 times m times v over 4 times f,
No,
because the mass is doubled. And if I take out the 2/4 and reduce it, I get 1/2 mass times velocity over force, which means the time here is 1/2 whatever the time here is.
I was totally right for some reason.
So the time is
Half the time.
time is halved when you double the mass and quadruple the force. A lot of people got this one right intuitively. A couple people tried to work it through.
I did it in my head.
I just completely
I
guessed.
said, like...
Did you get it right?
I did.
I honestly think some of you guys are better
It
than
doesn't
I am.
matter in physics.
Well, I honestly think that some of you guys are better at the conceptual stuff in here than I am. I don't really trust it until I work out the algebra.
I can't do algebra if I don't have equations.
All right, any questions on this? Set aside for a moment my expectation that you would remember that acceleration is velocity over time and to apply it, and keeping in mind that you'll have all of these equations still on every test this year.
Yeah.
But any questions on this once we plug that in?
Expect the unexpected.
Always. May I erase this now? Yeah.
1/2 mvf. Why do you know that the 1/2 is, like, if you wanted to get, like, why do you know that's the t?
Oh, because, well, here I had time equals mass times velocity over force. And the problem said, what happens if you double the mass?
Okay.
Yeah. So this time,
I got it.
I should have put like t sub 1 and t sub 2 or something. Maybe that would have been more clear, but possibly. Okay, good to know. All right, number 1. And that's... Now we go on to number 2. Number 2 is the astronaut on the planet, right? Far, far away?
Yeah, seriously,
Okay.
I thought there was going to be a Star Wars quiz.
I really did too. I thought they were going to go into
I don't
that
think
next.
the book can do this.
On a planet far, far away, an astronaut picks up a rock. The rock has a mass of 5.00 kilograms. Remember, mass and weight are 2 different things. It's a mass of 5.00 kilograms. And on this particular planet, its weight is 40 newtons. This is not a part of the problem, but I'm going to ask a side question right now. Okay? What's the gravity? What's the acceleration due to gravity on this planet?
Oh, no, it's not.
On this planet.
9.81.
Oh.
On
No,
this
'cause
other
it's
planet.
kilograms.
It's Earth.
So would it be in
8 meters per second squared.
8 meters per second squared. Force equals mass times acceleration. So on this planet, it has a weight of 40 newtons. Weight is the force exerted downward by a combination of your mass and gravity.
So weight is an acceleration.
Weight is an acceleration multiplied times a mass.
So that means.
So liposuction.
That's like we talked about yesterday. I have a mass of 90, basically I have a mass of 91 kilograms. So that's about 200 pounds
And
of force on the
6.25
floor.
slugs.
And 6.25 slugs we figured out yesterday.
What is a slug? Like, this is so confusing because it's like
Cousin of
I
Sam.
could be like I weigh 4,000 slugs. Like,
Well, no, you couldn't. No, you couldn't. That's a great point. That's a great point.
I don't know what that means.
Here's the big problem with that, and here's why. And it's going to take us a couple days to get through, but you guys have been using mass and weight interchangeably your whole life, and so have some of your science teachers. So have I probably in my math classes I've taught before I had to think about it this much. And in fact, if you convert kilograms to pounds, which you can do on the internet, you do in weight rooms, on scales, that's actually a mistake. The problem is you're taught metric units of mass, kilograms, but you're told that they correspond to British units of weight, pounds, and they're two different things.
Wait,
Mass is, I mean, the thing is, okay, you're told that somebody weighs something in kilograms, right? It's never correct to say something's weight in kilograms. Kilograms are a unit of mass. As we said yesterday in class,
Mass, it weighs pounds.
it weighs in
Does
newtons
that
in
mean the
metric.
metric system's wrong?
No, it means the way we talk about the metric system is wrong. Metric system's fine,
So
as
you-
long as you know that, 92 kilograms. What did we figure out yesterday? 92 kilograms is about what I weigh, and I exert a force on the floor of, like, it was 800 and something newtons.
895.
895 newtons.
Tubby.
Okay? In British units, that's 6.25 slugs we figured out yesterday, which works out to me exerting a force on the floor of 200 pounds. Okay, look at it this way. If you go up in an elevator, does your weight change?
No.
Yes.
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 Your head.
Does your mass change?
No.
No.
No, it does not.
No, not unless on the way up you amputate a limb. Your mass does not
Or you
change.
could cut off all your hair.
Where
You cut off all your hair. Yeah.
Which is easier.
where exactly is negative 9.81?
I believe sea level. 9.81 meters per second is sea level. So if you go to the top of Mount Everest, somewhere in your book there's a
Wait,
chart.
how do you have a